Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 2 in the CORS module titled CORS Vulnerability with Trusted Null Origin. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy, go down, select the learning path, go down, select cross-origin resource sharing, and then go down one more time. And select lab number 2 titled CORS Vulnerability with Trusted Null Origin. Alright, let's get started. This website has an insecure CORS configuration in that it trusts the null origin. So in the previous lab, it trusted arbitrary origins. In this lab, it trusts only the null origin. To solve the lab, craft some JavaScript that uses CORS to retrieve the administrator's API key and upload the code to your exploit server. The lab is solved when you successfully submit the administrator's API key. So we've got our target goal over here, which is to exploit the CORS misconfiguration to retrieve the administrator's API key, which is again the same goal that we had in the previous lab. You can log into your own account using the following credentials, and we've got the creds right over here. So let's right click on Access the Lab and open it in a new tab. And while that's loading, we'll open up Burp Suite Community Edition. Hit OK. Let's close this, hit Next, start Burp. And let's make this a little bit smaller. Go to the Proxy tab, set Intercept to Off, and then go to the HTTP History subtab. Now set Foxy Proxy extension in the browser to send requests to Burp, and then click on My Account. You should see the request go through Burp, which we do right over here. Alright, perfect. Now let's log in as the user account that was given to us. The password was Peter, hit Login. And notice over here we've got the API key. And if you look over here in the accounts details page, it's making use of an AJAX request. So it has the access control allow credentials CORS header. This way we know that the application is definitely making use of the CORS protocol. Okay, so the API key that's presented to us is the API key of the user that we logged into. What we're really interested in is the API key of the administrator. So what we're going to do is we're going to test the CORS configuration on this site to see if it's vulnerable, and if it is, then we could potentially exploit it in order to either phish the administrator or get the administrator to click on a link. And when the administrator clicks on the link, we're going to submit a request to this page over here and extract the API key of the administrator user. But again, before we do that, we need to confirm that this page is actually vulnerable. So to do that, we're going to send this to repeater, and let's make this a little bit bigger, hit send. We get a 200 OK response, that's good. Next, let's add the origin header to see if it accepts arbitrary origins. So we've got HTTPS, let's say example.com, and see if it accepts it, hit send. And notice over here we don't have the access control allow origin header with our example URL being added to it. That means it doesn't accept arbitrary origins, which is unfortunate. So we've got to move on to our next use case, which is changing, or let's keep it consistent, change the origin header to the null value. So there's legitimate use cases when you would use the null origin. So it's possible that the developers had configured CORS rules to allow the null value to be added in the origin. So we'll test for that. If that doesn't work, then we'll move on to our next test case to see if it's vulnerable to any other misconfigurations. So if we go back over here and we just add the string null, let's see what kind of output it gives us. Hit send. And here we go. So it gives us the access control allow origin header, and it tells us that the null value or the null origin is allowed to access resources in the application. And not only can it access public resources, it can also access private resources, so authenticated resources, because the access control allow credentials header is set to true. So this is the perfect use case for us because we have both headers set in the application. Now let's develop a proof of concept and then use the exploit server in order to send it to our administrator user. And to do that, let's save this first, and we'll write it up in the CORS Lab 02 HTML document, and I'll provide a link to that in the description. Okay, so we'll start off with initializing the HTML document. We'll add a body tag, and then a script tag. So this is really similar to what we did in the previous lab. We'll only tweak it a little bit so that we make it seem like it's coming from the null origin versus, let's say, localhost or from your malicious server. Okay, so again, we'll use the XML HTTP request object in order to request data from the web server. So let's say var xhr is equal to new XML HTTP request. And that didn't work out the way I wanted it to. So let's fix that. Next, let's set the URL. And that's the URL of the application. So we can get that from over here. Let's copy that. Go back to Visual Studio, add HTTPS, and put the URL. That looks good. Next, we're going to make the request. So we're making a GET request, and it's made to the URL. So that's the origin plus the page that we're requesting, which is account details. So again, it's the account details page because that's the one that is vulnerable over here and has the API key. And we're making a GET request because it uses a GET method over here to do that request. All right. Next, we need to make sure that the browser sends the user's cookies with the request. So we're going to use with credentials property and set it to true. So when the browser sees this, what it does is it sends the user's cookies with this request over here. Now, if access control allow credentials was not set to true, the request won't go through. But because in this scenario it's set to true, the request will go through and the credentials will be sent with the request. All right, last thing we need to do is send the request. Okay, this looks good. Now, once we've sent the request, we need to be able to extract the response of the request. So we're going to say on ready state change, run this function over here. So when the XML HTTP request object state changes, run this function. So we're going to say if the object's ready state is equal to done, then fetch the response of the request. So the response would be similar to what we did last time. So we're just adding a string over here so that we could easily parse the log of our server. And then we're going to add the response of the request. Okay, this looks good. So again, let's explain this. What we're essentially doing is we're making a GET request to the account details page, and we're telling the browser when the user clicks on this script or when this script runs, what we want the browser to do is send the credentials with the request. So the cookie that is stored in the browser gets sent with the request, which is important because we're actually requesting an authenticated page that has the API key of the administrator. So once the request completes, we fetch the response of the request and we add it in the logs of our web server. Now we add this string over here in front of the log because this way it allows us to parse the log easily. Now if we run this, it'll appear as if it's coming from the exploit server, so it could be maliciousserver.com or whatever your domain is. However, we saw in burp over here that if we had put anything other than null, so let's say https exploitserver.com and hit send, the request won't go through. And the reason we know the request won't go through because the access control allow origin header is no longer available. It only appears when we either put the origin of the application or we add the null value. So in this case, we added null, and it says that the null value is allowed to access the resource. So we need to alter our script a little bit in order to make it appear as if it's coming from the null origin. And that's actually much more simple than you would think. All you would have to do is add a sandbox iframe, and it'll appear as if it's coming from the null origin. So if we do this iframe, and we add the style to be display none so that it's completely invisible, and then we specify that it's a sandbox, and it allows scripts to be run, which is important because this is a script. And then we'll add src doc to be equal to this script over here. So let's close this up over here and close our iframe. So this does not look right for some reason, and the reason is because it's closing the double quotes over here. So let's change that to single quotes. And here we go. This looks a little bit better. Okay, let's save this. What we essentially did over here is we're just saying run this in as sandbox iframe, and this way it'll appear as if it's coming from the null origin versus coming from the malicious web server's origin. Now in this case over here, we're going to have to change this so that it complies with the web server itself. So for us over here, it would be the URL of the web server or the origin of the web server. And to get that, we're going to click on go to exploit server. And it's this one over here. So let's copy that. Put it over here. And let's remove exploit. Okay, so you got to specify it over here because it won't find it on its own since it's running in a sandbox. So let's save this and see if it works. Let's copy that. Put it in here. Store the exploit, deliver the exploit to the victim. So we're essentially just sending a link to the administrator user, and the administrator user is clicking on the link while the user is logged into the application. So if we look at the access log over here, we should be able to see a log key is equal to and then the response of the request. If we don't, that means we did something wrong. So let's go over here. And we don't, so something is wrong in our code, and it could be related to these tags over here. So for some reason, they're marking as red, and I don't know why. All right, I figured out what was wrong with the script. It wasn't the tags over here. I had made a mistake, and instead of saying allow scripts, I said allows script. So the script never ran, which is why we didn't see it in the log. So let's save this again and copy the whole thing, put it back in our exploit server, hit store, and then deliver exploit to victim. And hopefully now when we click on the access log, we should be able to see the API key of the administrator. And we do. Perfect. So you could see the string over here that we had specified. And you could see the username is administrator and the API key is right over here. So it starts off with E and ends with 3. So let's copy that. Submit solution and hit OK. And here we go. It says congratulations, you solved the lab. So let's go back to the exercise over here. Alright, so we successfully completed the exercise by exploiting a CORS misconfiguration in the application that allows the null origin to access any resources in the application. Now we did it using the exploit server because the Web Security Academy wants you to have a server in order to be able to submit the solution to the administrator user, and then the administrator user clicking on the link while the user is logged into his or her account. However, if you found this in a real application and you want to show a proof of concept to the client, what you would do is you would need to host it on your own web server. And a really simple way of doing that is just hosting it on a simple Python server. So we're going to click on New Terminal, and then we're going to spin up a simple Python server to host our script on. So in this case, it would be simple HTTP server and running on port 5555, hit enter. And what this is doing is it's hosting this script on localhost port 5555. Now, one thing we do need to change with the script is the exploit server URL, because it's no longer hosted on the exploit server of the Web Security Academy. Instead, it's hosted on localhost. So we're going to remove this. And we're going to say 127.0.0.1, and we're going to click on save. To save this, I don't know if it's automatically regenerates the script, so I'm going to Control-C this, clear it, and then spin up my server again. All right. So the way you would showcase this to the client is first you would ask for administrator credentials and then play the role of both the administrator and the user that is phishing the administrator. So assuming that the administrator is logged into his or her account, you ask the administrator to click on this link over here. And then you hit enter. And while the administrator is looking at this empty page, you should see over here the response being logged in the logs of the web server. And in this case, we don't, which means something is wrong. So let's right click, inspect element, go to debugger, go to console, and see what's wrong. Alright, I paused the video and figured out why this was not working, and the reason it wasn't working is a mistake from my end. So first of all, this is HTTP, and second of all, when we were hosting the simple Python server, it was running on port 5555, and that's why it wasn't working, because it couldn't reach the IP address itself. So if we run it again, so we're hosting this script over here, and we didn't save this script, so we're gonna have to Control-C this, clear it again, save the script first, and then run our Python server again. So now it's hosting this script. Now if you click enter over here, again, all the user sees is an empty page. You could, of course, make this a little bit more realistic by adding, hello world, or adding a full-on page to the application where the user is scrolling the page. And what's happening in the background is that the application is making a request to the account details page and extracting the API key of the user. Now, in this scenario, we're only logged in as this user over here. So the regular user account that we were testing with, and that's why we retrieved the API key of this user. However, if we had phished an administrator user and asked the administrator user to click on that link, then the administrator's API key would be the one that gets logged in our web server's logs. And that's how you would show a proof of concept when it comes to a real application. So you would request an administrator account, and then you would play both the role of the victim administrator user and the role of the malicious users. So the user that creates the script and sends it to the administrator user. And then from there on, you explain to the client that when the administrator user clicked on the link, the API key of the administrator user was logged on your malicious web server. Alright, so we successfully completed the exercise by exploiting a CORS misconfiguration that allowed the null origin to access authenticated pages in the site. In the next lab, we'll look at another misconfiguration that we can exploit in order to retrieve the administrator's API key.